All right, welcome to our next topic for chapter 2 with our data analysis, which is dimensional analysis. Dimensional analysis is a tool that we use in chemistry a lot, and it's used to help us convert from one unit to another. And we really come back and visit this hot and heavy when we get into second semester. Right now, though, we're going to talk about it in terms of just data and how to convert from one thing to another. So, what I have here is a sample. We've got a safari here. We're going to go out on a safari, and they've told us that while we're out on a safari, that we have certain animals that are equal to each other. So, for example, we've got 3 hippos equal to 4 zebras. So, for every 3 hippos, we have 4 zebras present. And for every 1 zebra, we've got 2 ostriches present, and so forth and so on as we move across here. So they're asking us if we know that we have 3 cheetahs, how many zebras would be present? So we've got to be able to use these cards, and we can flip these cards around. So if we want to cancel out things, we can. If you remember, something divided by itself ends up being 1. So if we want to get rid of cheetahs here and we want to get 2 zebras, we find our cards that have cheetahs on them. And then we try to figure out along the way how we can get to and eventually cancel out zebras. So if I look at this card here, I see that I've got a giraffe and a zebra, which the zebra is where we want to end up at. And I have a card with a giraffe and a cheetah on it. So I'm going to grab this card and I'm going to bring it up here. And if I divide cheetahs by cheetahs, that equals 1. So we're canceling out units, not numbers, but we're canceling out our units. So if I divide a cheetah by a cheetah, I have 1. The cheetahs go away. And at that point, I'm left with giraffes. And if I grab this card, I can bring it up here. And now giraffes divided by giraffes end up being 1, and that leaves me with zebras. So then what I have to do is I have to multiply across the top and then divide by the numbers on the bottom. And what I'll do is I'll end up having um, zebras left over. And I can end up canceling out units. So my cheetahs will cancel out because they're going to divide out to be 1. They're gone. And my giraffes will cancel out and they're gone. They divide out to be 1. And then that leaves me with my zebras. So if I multiply 3 times 20 times 3, and then I divide the whole thing by 2, because 1 times 2 is 2, then I'll end up having all of that canceled out. And if I multiply that with a calculator, it ends up being 90. So that gives you kind of an idea of how we're going to do this. And this is called dimensional analysis. My cheetahs canceled, my giraffes canceled, and that ended up leaving me with zebras. So 3 times 3 is 9, times 20 is 180, and then 180 divided by 2 gave me my 90 zebras. All right, so let's try another problem here. You can pause the video and see if you can figure it out yourself. I'll kind of bring it down here so you can see some of the conversion factors. We're trying to get 6 giraffes. We're trying to figure out how many elephants would equal 6 giraffes. So here are my giraffe cards. I've got a giraffe card here. I've got a giraffe card here. I've got one here. And you have to kind of play with these and turn them around until you can figure out exactly how you're able to get everything to cancel. So let's try to do that real quick here. I can see here that I have a giraffe and a zebra. I can see that I only have one elephant card. So if I drag that up here, that's going to help us out just a little bit because we know that we've got to go through a cheetah to get there. And I can see here that if I drag this card up, I have a cheetah and I have a giraffe, but I need to get rid of giraffes. Right now I'm multiplying giraffes, which would give me giraffes squared, and that doesn't help at all. But if I take this card and I flip it around, which is completely allowable, now my giraffes will cancel out, and I can bring this over, and my cheetahs will cancel out, and that's going to leave me with elephants. So if I multiply across here, after I've canceled everything out, I can take the pen here and cancel my giraffes. They're gone. My cheetahs are gone. And that's going to leave me with elephants for my units. And then I need to multiply across the top. So 6 times 1 times 7 is going to be 42. And that's going to be 42 over 20 times 2 is 40. So when I do the math out for that with my calculator, I end up getting 1.05 as far as my answer is concerned. This kind of makes it a little bit neater and more seamless for you. So the next one then that we're going to do is this problem. And sorry. So problem 3, we have rhinoceroses and we have ostriches. So they want to know with 40 ostriches how many rhinos we would end up having. So I only have one card with an ostrich on it. So I'm going to drag that guy up here. And then I'm going to look to see if I have a zebra and a rhino. And the only rhino card that I have is this one. Looks like, nope, I'm sorry, I take that back. I've got one here with the giraffe as well, and I've got one here with the gazelle. So let's see here. I've got the giraffe. If I take the giraffe, and do I have a zebra and giraffe? Yes, I do. Okay, so I can take this card. Right now, with the present card, the way it's sitting, I would end up with giraffe square, or I'm sorry, zebras squared. I don't want zebras squared. I want to get rid of zebras. So if I flip the card around, I'm able to get rid of him. I can bring this card in, and that's going to get rid of my giraffes and leave me with rhinos. So my ostriches cancel, my zebras cancel, and my giraffes cancel, leaving me with rhinos. And if I multiply these values across the top and divide by the bottom, I end up with an answer that's 2 rhinos. All right. The next one then, we're trying to figure out giraffes, how many giraffes there are if we have 2 lions. So if I have 2 lions and I'm trying to go to giraffes, so I've got a card here with a lion on it, and that's the only card I have with a lion. So I'm going to have to bring him up. I'm going to get rid of lions, so he's sitting in the right spot. Now I need to get rid of hippos, and I need to see if I have a hippo and a giraffe card. And I've got a hippo card that I just placed there, so we don't want to use that one again. We've got a hippo card here, and that appears to be the only one that we've got. So I'm going to bring him up here. So my hippos are going to cancel. Now I've got zebras, and I'm trying to go zebras into giraffes, and I've got a card here that will allow me to do that. But again, this is going to give me zebras squared. I need to get rid of zebras. So if I flip it over, then I end up with the correct way of doing this problem. So just double checking, my lions are going to cancel, my hippos cancel, my zebras cancel, and that's going to leave me with giraffes. And when we multiply across the top and we divide by the values in the bottom, we end up with an answer that is 7.11 giraffes. Moving on to the next page here. We are trying to get impalas. So we need to know how many impalas we have for every 9 hippos. So if you want to pause the video, here are those conversion factors. I would suggest that you try to see if you can get this one set up on your own, and then start the video back up and try it. All right. So welcome back. And we've got a hippo here, and we've got a hippo here. Well, with the hippo and the lion, I don't have anything else that I can move through. So this is not going to be a good option. I'm going to bring this guy up here, and then I'm going to look to see if I've got an impala here. So I've got an impala and a rhino. And I have an impala. I'm sorry, I've got a rhino and I've got a giraffe, but the rhino's on the wrong side, so I need to flip that around. So I'm sorry, I had it right. So those will get rid of each other. And then I do have a zebra and a giraffe here, but again, this is not going to cancel out. So I've got to flip this card around. And now my zebras will cancel, my hippos will cancel, my zebras cancel. I bring this guy over, and you can see here that my giraffes will cancel, my rhinos cancel, and that's going to leave me with impalas. So hopefully you were able to get that you ended up with 60 impalas. And the next problem here, we end up with ostriches and elephants. So for every 2 elephants, they want to know how many ostriches we have. So pause the video and see if you can figure that out. All right, we've done elephants before, so we know that this is the only card with elephants. So we're going to need to get from cheetahs to elephants. To get rid of our elephants, we need to get rid of them. So we've got to cancel them out. So bringing that over here, we know that we're going to have to go through cheetahs. The only card that ostriches are on is this one. So we know that we need to end with ostriches. So we want to end with ostriches on top. So I'm going to slide him over, and then I'm going to look to see if I have a card that's a cheetah to a zebra. So I've got a zebra here with a giraffe. I've got a zebra here with a hippo. So neither one of those is going to work, but I have a card here that is a cheetah and a giraffe. So I can take this one, and I can get rid of my cheetahs here because they're going to cancel. And then I can bring this one up, and I can get rid of my giraffes, they cancel. And then if I bring this one in, my zebras will cancel. And so once you do the math on these, you multiply 2 times 2 times 20 times 3 times 2, hit your divide key, and remember when you go down, you need to put this stuff in parentheses in your calculator. So this is going to be parentheses 7 times 1 times 2 times 1 in your parentheses and hit equals, and you should come up with 34 ostriches. All right, so this is really practical for these types of problems where we have these cards. But most of the problems that we have come from some sort of conversion table or just things that we commonly know. So here's a sample problem like you might see on a test or a worksheet or something like that in chemistry class. Let me switch over to a pen here so it's a little bit easier to write on. All right, so how many seconds are in a day? Well, I don't know how many seconds are in a day, but I can put down that I'm starting with 1 day. So this is what I'm going to do is start with 1 day. And I know that I want to get rid of days. So whatever I want to get rid of, that unit I want to put on the opposite side. So right now I've got days here. If I divide by days, then they're going to cancel out and become 1. So I want to get rid of days. So I'm going to put that unit on the other side. I don't know how many seconds are in a day, but I do know how many hours are in a day. So just like some of the problems that we just saw, sometimes we have to do multiple steps on these to get everything finished up. All right. I always put my units in before I put my numbers that are accompanying them. The problem is that when you try to do both things at one time, you often flip around where the numbers should be. And if you have the units in here, now you can say to yourself, oh, I know that in 1 day I have 24 hours. It's a very common mistake that people will flip these numbers around for some reason. The brain just doesn't work well with them. So that's what I always suggest you do. Put down your units first and then put down your numbers. All right. We're still not where we need to be here. We're at hours. We need to be in seconds. So I want to get rid of hours. So I'm going to put hours on the opposite side because then they will cancel out. So I'm going to put hours down here. And I do know that in 1 hour, I have 3,600 seconds. So I can go ahead and put seconds in here because I know a conversion factor between these two things. And I know in 1 hour, I have 3,600. Sorry, it's hard to write with this sometimes. 3,600 seconds. And so now I go back and I just double check my units to make sure that they're canceling out. So days are going to cancel out, hours will cancel out, and that's going to leave me with seconds, which is what they're asking for here in the problem. All right, so then I grab my calculator and I just multiply 24 times 3,600, and that ends up with 86,400 seconds. And don't forget your units. I'm a real stickler with those. All right, so hopefully that kind of helped you. Again, you're going to be given conversion factors for anything that's not just common knowledge. If it's on a test and I thought it was common knowledge and you're like, I don't know how many seconds there are in a minute, or I don't know how many seconds there are in an hour. If you raise your hand, I will tell you what those are. So I don't expect you to memorize any of these types of conversion factors. They will all be provided for you throughout any test or quiz. All right, so now if we wanted to know how many hours there are in a year, we're going to start out with 1 year. And we can see here that we've got 1 year is 365 days. I know there's leap years and that sort of thing. We're just going to kind of ignore that for the sake of this problem. I want to get rid of years, so I'm going to put years on the opposite line. And I know from this conversion factor that I can go into days. And again, I write down my units before I write down my numbers. So in 1 year, there's 365 days. I need to get rid of days and go into hours. And I know that in 1 day, there's 24 hours. And there again, I should have written my units down and then written in the numbers. So I apologize for not following through what I've just told you. All right, so let's throw that under our calculator. And I end up with 8,760 hours. All right. So here's another problem that we have. How many miles will a person run in a 10-kilometer race? So I don't give you conversion factors within the metrics, but I would give you this as far as miles and kilometers. So let's see here. We should have a conversion factor up here. Miles and feet. Here we go, miles and kilometers. So we're going to use this conversion factor right here to solve this problem. We have a 10-kilometer race. I want to get rid of kilometers. So kilometers are going to go on the opposite side. And I'm going to put in my kilometers. And then I'm going to put in my miles up here. And then I'm going to go back in and fill in my numbers. This is a 1, and this is going to be 0.621. So our answer to this problem is going to be 6.21, and that's going to be miles because our kilometers canceled out. All right, so try this problem and see what you end up with this problem. It's going to be like the last one, but it's going to be an extra step or two. So pause the video and see if you can figure this one out. All right, so hopefully you had a chance to figure this out. We've got 16.25 miles. I want to get rid of miles. So miles are going to go on the bottom. I'm going to go into kilometers because that's going to get me into the metric system, which centimeters is part of that. So we're going to get there. So I'm going to go to kilometers here and grab my numbers in just a second. I know that for every 1 kilometer, I have 0.621 miles. Now, I need to get my kilometers to centimeters. You may not have some of these memorized, so there's certain ones that you need to get committed to memory. I know that for every 1 kilometer, I have 1,000 meters. So that one should be a pretty easy one for you to remember. And then if you think about the meter sticks that we use during the Sig Fig demo, I know that I've got a conversion factor between meters and centimeters. And I know that for every 1 meter, I have 100 centimeters. So now I just need to grab my calculator and divide this out. So 16.25 times 1,000 times 100. I'm going to hit divide, begin my parentheses, put in my 6.21 times 1 times 1, end my parentheses, and hit equals. All right, so once I do that, I end up with 2,616,747, and that's going to be centimeters. And if you think about that, I mean, you know how long a centimeter is, and you know how long a mile is. That's like 4 laps around the track, okay? There's a lot of centimeters in that many miles. So kind of when you're done with these, kind of sit back and kind of look at the answer and see if it makes rational sense. All right, here's another one. This one, they give you all the conversion factors in here, except for the fact that you may have to change between weeks and years. All right, but this is kind of a double-edged one. So what you have to look at here is that we know that they eat 14 bales, 14 bales. And that's over the period or per 2 weeks. Okay, so that's how we would set that up, where we end up with having 2 units, one per another unit. Now, we know that in 1 year, we have 52 weeks. So right here, we're going to use that conversion factor. I want to get rid of weeks, and I want it to go into years. So I want to put the thing that I'm dividing it out of on the opposite side. So if I want to get rid of weeks, I'm going to put weeks on this side of my setup. And I've got a conversion factor to go into years, and that's what they wanted us to find out, was how many bales they would eat in a year. So if I put my units down first, and then I go back in and I fill in my numbers, I've got 52 here, and that's in 1 year. All I have to do is just double check to make sure that my units canceled out, and that's going to leave me with bales per year. So if I take my calculator and I go 14 times 52, hit divide and divide it by 2, that's going to tell me that they're going to eat 364 bales per year. All right. All right, so that takes care of that problem. We got one more that we're going to go through, and this one is miles per hour, and they want us to convert this into feet per second. So we know that we're traveling at 50 miles per 1 hour. All right, we have to convert both of these units to something else. And it doesn't matter which one you start with, just as long as you get them both done. So I'm just going to start out with miles. I want to get rid of miles, so I'm going to put miles on the other side. And we're going into feet. So we're taking miles into feet. So we want to try to find conversion factors up here that would work with that. So let's see here. Right here. So here's our conversion factor for miles and feet. So I'm going to get rid of miles. I'm going to put miles down here. I'm going to put feet up here. And then I'm going to go back and put my numbers in. In 1 mile, there's 5,280 feet. All right, so that takes care of my feet issue. Now, if I look at my cancellation, right now I have it, miles are gone away, they've canceled out, and that's going to leave me in feet per hour. But they don't want to know per hour, they want to know per second. So now I need to get rid of hours. So I could put hours on the opposite side to get rid of them. So they're going to end up canceling out because they're on the opposite side. And I can convert that into seconds because I know that in 1 hour, I have 3,600 seconds. All right, so just to confirm that everything's canceled out and that leaves us where we want to be, our hours are going to cancel, and that's going to leave us feet per second, which is exactly what they wanted us to do here. So grab your calculator. 50 times 5,280 divided by, begin your parentheses, 1 times 1 times 3,600 in your parentheses and hit equals. That's 73.3 repeating. So 73.3, and that's going to be feet per second. All right. So you have some homework problems to practice with these. Try to give it a shot, see what you can come up with. And as long as you've showed me that you're trying, and I need to see your setup, not just the answer for this. As long as I can see that you're trying, we're good. So I want to see that you're trying the homework problems this evening. So good luck.